So welcome to today's video lesson. We will be proving the tangent segment theorem, or this equation right here. The angle A is equal to arc BDC, this major arc, minus arc BC, this minor arc right here, is equal over 2. Yes. So disclaimer: I will not be using two-column proof, and this shall not be used for any malicious intent, and this should only be used for educational purposes only. So let us start. Let us first draw the line EC. Point E. Also note that segment AB is congruent to segment AC because of the theorem that states that two tangents that come from the same point have segments that are congruent, where those segments come from the same point to their respective points of tangency. You may have heard this in a different way, but this is how I just interpreted it. So yes, feel free to come back at that in your notes. Yes, let us continue. Now let us draw the segment BC. Now let us draw a segment from A to segment BC. Let's label this point of intersection as F, where segment AF is the height of this isosceles triangle. Now why is this an isosceles triangle? Because automatically there are two congruent sides, which means it is an isosceles triangle. Now, since this is the height of an isosceles triangle, this must mean that angle A is bisected into two congruent angles, and it is perpendicular to BC, and it bisects BC into two congruent segments. Now let us draw the segment EF. Oh wait, sorry. My drawing of center E there is not optimal. There. E. Let us draw the segment EF. Now since this segment comes from the center and it intersects BC at its midpoint, which means it bisects it, it must also mean that it is collinear with AF and is now perpendicular. It forms a linear pair because it is collinear. We have established that. So this is perpendicular. Sorry, wait. Double lines. Now let us draw the segments BE and CE. Note that BE and CE are congruent because they are both radii. Now let us draw another segment, ED. Also note that this is another radii because it comes from the center and it intersects a point on the circle, so it is radius. So it is congruent with all the other segments with the previous two radii. Now we have established that. Now let us draw the segments BD and CD. Notice how we have formed three isosceles triangles. Yes. So we can label these angles as X. Wait, sorry, I'll label these first angles actually. These as Y. And now since we've also established that EF is collinear, that must also mean that ED is collinear. And since it is perpendicular to BC, it must also bisect D. So this is Y. And since triangle CED is an isosceles triangle, this must also be Y. Note, however, that we cannot assume this angle right beside Y here and right here too is also Y, because we don't know if segment BC is congruent to segment BD or CD, because the triangle congruence theorems. It is incomplete. So let's label these angles right here as Z. Now we know these two are congruent because this is part of its own isosceles triangle. So now let us establish our equations. Wait, let us label this angle right here beside Z as alpha. There, alpha. Now let us establish our equations. So arc BDC, sorry for my terrible handwriting, can be broken down into arc BD plus arc CD. Now we can turn arc BD into these variables right here because this is an inscribed angle. Now let's recall the inscribed angle and intercepted arc relationship. The inscribed angle, twice the inscribed angle is its intercepted arc. So that means BD, this segment right here, this arc right here, is twice the measure of Z plus Y. Yes. Now, same goes for CD. CD, this arc right here, is twice the measure of, again, Z plus Y. Again, these are doubled because this is an inscribed angle, and recall the inscribed angle and its intercepted arc relationship. Simplifying, we have 4Z plus 4Y. Now, to get arc BC, this minor arc right here, wait, I'll label that a different color, sorry. Yellow, this arc right here, arc BC. That sucks. Orange. Yeah, arc, pink na nga lang, just go. Blue, yan. Arc BC, here, it has its own angle. This right here, angle D, which is merely Y plus Y. And remember, the inscribed angle and intercepted arc relationship, arc BC must be twice the measure of this right here, which is just Y plus Y, simplifying 2Y, which is equal to 4Y. So that must mean arc BDC minus arc BC is equal to, again, BDC minus BC, 4Z plus 4Y minus 4Y. We cancel out the 4Y. It must be equal to 4Z. But since we still have to divide that by 2, again, we just have to divide the whole equation by 2. So this becomes 2Z. Now that we know this information, we now need to prove that angle X is equal to angle Z. Because once we prove angle X is equal to angle Z, once we twice that, 2X is equal to 2Z, that would mean that 2X angle A is the difference, the one we are trying to prove. So let's do that now. Note that since segment AB is tangent to the circle, this must mean that A plus Z forms a right angle. Because it is tangent, that is the definition of the tangent of a circle. So A plus Z is equal to, 90 degrees. Again, definition of tangent of a circle. Now, we can also write that X plus 90 degrees plus A, alpha, all the lowercase a here, sorry, I should have been referring it to alpha so far, but yeah, my mistake. X plus 90 degrees plus alpha is equal to 180 because the sum of all angles of all interior angles of a triangle is 180 degrees. That is the definition. So simplifying, we get that x plus a is equal to 90 degrees. Now transferring that to our previous equation here, using the law of substitution, we get that alpha plus z is equal to x plus alpha. Now subtracting alpha from both sides, we have now proven that x is equal to z. Now let us multiply both sides by 2. Note that 2x is equal to angle A, and 2z, as we have learned earlier, is this part right here. So substituting this, we get that arc BDC minus arc BC over 2. Yay! Thank you for listening. Again, if you have any questions, feel free to ask, and also share with your other people you may know. And if you have any rebuts on this proof I have made, please let me know, because I have made an error. So yes, thank you.